session on multi-factor productivity, where we're going to select a process based on multi-factor productivity. So we have two processes, process alpha and process beta, and we'll calculate multi-factor productivity for alpha and for beta, and we'll compare and we will choose the most productive process here. Okay, so this is really good to learn. So we're gonna get started here. First of all, let's review productivity itself. What do we mean by productivity in operations management? This is how efficiently do we transform our input into output. That's the definition of productivity in operations management. So productivity has to do with efficiency. How efficient are we in transforming input into output? So let's first review the type of productivity. So there are three types of productivity. Partial productivity, right? An example here is labor, capital, machine. So partial productivity means that when you compute productivity, you only use one input in your calculation. So only one input is being used here. And then you have multi-factor productivity. Some people say multi-factor productivity. I can say multi-factor productivity, where we use more than one input. So if you use more than one input, that's going to be multi-factor productivity. So we can use labor, capital, and machine to calculate productivity. Then we're going to call that multi-factor productivity. And sometimes it is labor, capital, and overhead. So it depends. When you use more than one input, it's also what we call factor. So multi-factor here means multi-input. So now the total productivity is where you use all the inputs that were used to transform this input into output, right? If you can take into account all of the input, then we call that total productivity. So let's see productivity measure. So how do you measure productivity? In general, productivity, mathematically speaking, is the ratio of output to input. So for example, partial productivity will be the ratio of output to a single input. An example here is labor. Labor productivity is going to be the output divided by the single input being labor. And multi-factor productivity is all the output produced divided by labor plus material plus overhead in this case here. So make sure that the value of the output and the input are calculated over the same period, right? Month, weekly, and so on and so on. So here, let's see an example. So this company that I just called Essila Production, right? They produce a light board for video production, and they have a plant here in Michigan. So they want to choose between process alpha and process beta to manufacture part A and part B of a light bulb that will be used for video production. Each of the two processes can actually make component A and B, but here we want you to help Kelly, the plant manager, to select the most productive process by comparing each process label and multi-factor productivity. So some information that we have here, the first piece of information is that the process output, it doesn't matter whether it's coming from process alpha or from process beta. The value of the output for component A, we sell them for $190 per unit. And the process output value for component B is $180. And then the overhead for process alpha is $6,000, and the overhead for process beta is $5,000. So the accounting department has provided some information that we're going to see here to help the operations manager here to make that decision to choose the most efficient process. So here we have that information. So this is a page that you might pause and then take a picture and analyze it very well. So here we have process alpha. If you produce the output A and B, and process beta, the output A and B. So the output from process alpha, A we have 50 and B we have 60. And from process beta we have 30 and 80. And we have the labor cost to produce A, the labor cost to produce B for alpha, the labor cost to produce A, and the labor cost to produce B for beta. We also have the material. And we have the output that you already know, right? The value of A is $190 and the value of B is $180. So the overhead for process alpha is 6,000 and for process beta is 5,000. So what we're going to do here is we're going to put this number here. B is going to come here, 180. The same B is coming from here also for process beta. And then A comes here, and A for process alpha comes here. So we can calculate the output for process alpha, right? The total value of the output for process alpha is 20,300, and the total value of the output for process beta is 20,100. So we also calculate the labor. Everything in a yellow color here is about the cost. So we calculate the cost for process alpha and we calculate the cost for process beta. So we know that productivity, for example, the labor productivity is then going to be the total output divided by only labor. So labor productivity for process alpha here is 7.81 and labor productivity for process beta is 6.7. Multi-factor productivity for process alpha is 1.44 and for process beta is 1.56. So we can see that process alpha with 1.81 in terms of labor productivity for process alpha is higher than that of process beta, because process beta only have 6.7 and process alpha has 7.81. And then process beta here in terms of multi-factor productivity has a productivity of 1.56 multi-factor productivity for beta. A multi-factor productivity for alpha is 1.44. So we can see our finding here. So we want to now know by how much alpha outperforms beta in terms of labor, and by how much beta outperforms alpha in terms of multi-factor productivity. So we're going to use something called the productivity graph. So productivity graph to compare this process is going to be productivity of alpha minus productivity of beta divided by productivity of beta. Again, we multiply by 100%. So remember from the previous slide that labor productivity for alpha was 7.81 and labor productivity for beta was 6.70. So when we calculate productivity growth, we see that labor productivity for alpha is 17% more than that of process beta. So process alpha beats process beta when it comes to labor productivity. So we're going to do the same thing here for process beta and alpha in terms of going to compare multi-factor productivity. So when we calculate multi-factor productivity growth to compare the two processes, we can see that we have, based on multi-factor productivity, process beta is 8% more productive than process alpha. So now decision time, right? Managerial decision time, right? So we have our report here, right? Remember, for labor productivity, alpha beats beta, and for multi-factor productivity, beta beats alpha. So based on multi-factor productivity, beta is 80% more productive than alpha, and alpha, based on labor productivity, process alpha is 17% more productive than process beta. So, but overall, because multi-factor productivity also includes labor, it includes material and overhead, we will recommend to select process beta, right? Because process beta, in terms of multi-factor productivity, it will include labor, right? So even though alpha beats beta in terms of labor productivity, but because multi-factor productivity include many factors, including labor, so we're going to select process beta, but we're going to recommend that the manager, Kelly, the operations manager here, must use lean principle to improve better labor productivity, because we saw that the productivity of process beta was not good at all. Alpha beats beta by 17%. So because we use multi-factor productivity, is more inclusive, it has more input than just labor, so that's why we pick it. So let's see some of the options that the Kelly, the operations manager, has here to improve process beta labor productivity because it was low. So the first thing here is the defect, right? So lean consider defects as being a waste. So in terms of labor here is the time that the might spend on defective product and correcting them. So I think that could be what is causing this. The worker ideally wait due to process inefficiency and delays. The fact that they are waiting, that could be the reason that labor productivity is low. Unnecessary transport, moving products and material without adding value, right? Excess inventory, causing extra handling and storage. If you have excess inventory, you will spend time transporting them, moving them, right? And then unnecessary movement, worker excessive or inefficient movement that do not actually add value. So the operations manager here will have to examine what's going on with process beta to improve labor productivity for process beta, right? So as a summary here, we review the types of productivity. We say that we have partial productivity. Example is labor productivity or machine productivity. Partial productivity means single input will be taken into account. And multi-factor productivity will mean that more than one input will be taken into account. And then the third types of productivity is total productivity, where all inputs that were used will be included in the calculation. And then we use productivity comparative analysis using productivity growth models. It helps us to calculate by how much alpha beats beta in terms of labor, and then by how much beta beats alpha in terms of multi-factor productivity, even though we consider multi-factor productivity better indicator because it's already including labor. So we talk about the lean principle to improve productivity, and that's all I have for you today, and we will have another video. Thank you so much for watching, and I will see you next time. Bye bye.